ఈ వీడియోలో I'm going to explain concept of resistance and Ohm's law. So we know that in this universe every physical object is made up of material, and those materials are made up of atoms, and atoms are having protons, neutrons and electrons. Electrons are revolving around the protons. So outermost electrons also called free electrons. So all these materials are classified into broadly conductors, semiconductors, and third one is insulators. Now we will see about conductors. Let us consider some examples of conductors: silver, copper, and aluminum. So at a room temperature, that is at a temperature of 27 degrees centigrade, some of the thermal energy is absorbed by the those free electrons, and they are coming out from their valency band. So if you observe silver, silver is having one free electron. So I can represent this silver conductor as a silver ion with a one electron free, means one electron is available here. Coming to the copper, there are two free electrons are available. Coming to the aluminum, there are three free electrons are available. So as per definition, if you see the flow of electrons are we defined as a what? Current. So I is charge movement dq by dt or q by t. So by seeing these free electrons, if you see the silver is having highest free electrons, but this is having less conductance or conductivity when compared to the silver. So among these three materials, my silver is having highest conductivity even though it is having one free electrons. So why this silver is having high conductivity? Now consider a material, silver material or silver conductor like this. Let's consider this length of the conductor is L, and this conductor having silver ions like this, ions and free electrons I am representing like this. So like this, the whole conductor is having free electrons. Now the cross sectional area is A. Now I am applying an external field with the polarities like this, and the field is flowing in this direction. This is my external field direction. Now, upon applying this external field E, these these free electrons will acquire the energy and they will start moving. So, when the external field is applying here, whenever these free electrons are acquiring the energy, so they will move along the field direction or in align with the field direction. That velocity is given by Vd called drift velocity, given by the equation mu into E, where E is applied electric field and mu is mobility of free electrons. Units are meters per volt second, and this is volt per meter. So this equation gives that my drift velocity of the electron or movement of the electron is proportional to the applied field. So here mu is mobility of free electron is the proportionality constant. So how much kinetic energy acquired by my moving electron? That is given by half into m e Vd square, where there are so many joules, where me is called effective mass. What is meant by effective mass? So this is the total mass of the free electrons when they are in moving. So this is called effective mass. So these are the total mass of the electrons when they are in motion. Now, generally this m into E. Now consider when my field is not presented, that is E is 0. So if E is 0, then force on the electron is given by the equation from the field theory, that is Fp is equal to E into charge. So where E is 0 means there is no force on the electrons. So this term is 0. So if there is no force on the electron is 0, then my drift velocity is 0. So there is no movement. Then my kinetic energy is equal to 0. So here drift velocity 0 means here when external field is absent and the conductor is at some temperature T, the electrons in the conductor will move randomly like this, because even though there is no field, but because there is a temperature, these electrons moves randomly like this. So upon considering a cross section like this, so charge flow through this conductor, net charge flow through this conductor will become 0. So here drift velocity 0 means this is the meaning. Now, when E is not equal to 0 means there is some force existed on the charge where Q is, so here units are newtons. Here Q is total charge. So it is given by N into electron charge, single electron charge. So multiply with the number of electrons inside a conductor will give the total charge. Now the charge on the electron is given by 1 minus 1.6 into minus 19 coulomb. So if you see here, this is minus E into N into E. If you observe, the force on the electron is represented with negative symbol. What it mean? So if you applying the field like this with the polarity plus here and negative here, the electrons here definitely move in this direction because this is the positive polarity and electrons having negative polarity, so they will attract towards the positive plate or positive field. So force on this electron is having showing a negative means this is the direction, and because of that reason we are consider that my current is negative to the flow of electrons. The external field is presented here in the conductor. Now all random moving electrons are try to move in the field direction. So they are aligned with the field. So in this case, what happens? If you consider a cross-sectional area like this, now the net charge crossing this area is not equal to 0. It is something, some value. So if I increase field E, if field E is increased, then the force will increase, implies drift velocity increases, implies all electrons acquire the kinetic energy also increases. Now they will move with a faster rate. So the amount of charge is crossing this cross section area current per unit area is given by current density. Units are ampere per meter square. Now this current density is proportional to the applied field, which means as my field is increases, then the amount of charges crossing this unit area is increases, which means current increases. As current increases, current density increases. So this J will increases. So I can write this J is equal to sigma into E, where sigma is called conductivity. So this is called Ohm's law in field theory, and this equation is valid from 0 to any higher frequencies.